right, let's get started. Good morning, everyone. So where are we at in the course? We're about to start module 2, okay? So by now, I'm really hoping that everybody is starting to get in the groove with the cycle of new modules being released and what kind of learning activities we are going to have in each of them, okay? If you're not feeling comfortable, ask questions on Piazza, but generally after 2 or 3 modules, everybody is on board and ready to go. So we talked about building blocks, recombining them together in module 1. Okay, so that's, I cannot stress that enough, okay? This is your bread and butter. This is what you have to know 100%. It's not that you just have to be okay with it, or you have to remember some of it, or kind of understand what it is about. That stuff needs to be 100% loaded up in your brain, okay? Ready to use, no hesitation, okay? So I'm going to ask questions in class, etc., as we work together to write code. Whenever you are stuck, this is a warning, right? This is a red flag. That means I should know that. I'm not going to ask you complicated stuff, but I'm going to poke and poke and poke until I have a feeling that most of you are actually up to date. If you're not up to date with module 1, the rest of the course is going to get worse. That's it. There's no way around that, right? So if you haven't worked yet in this course because you had a little bit of background, etc., just make sure, start now, make sure module 1 is rock solid. So what are we going to do now that I supposedly presented to you everything that we can do in a computer program? What's left? Well, what's left is actually programming, writing the code. Programming means in this class, in the next, in all of the classes you're going to take at USF, programming means solving problems, okay? So when we look at programming as a skill, one of the mistakes that we did in the past, we meaning teachers or even learners, one of the mistakes we made in the past was to think that programming was this monolithic skill, this one skill. You learn programming, you know programming, that's it, you can program, okay? And over the years, what we realize is that most of the people that have problems learning how to program, they don't have problems learning how to program. They have problems with a specific subset of skills that we need for them to be able to program. So when you guys are going to program in this class, the next class, etc., you are going to use about 5 different skills, okay? And the way that we introduce those skills before to students, and the way I learned as a student, is somebody would show me good example of programs. And in some culture, actually, that's learning. If I just keep showing you, this is a good program, see what it does, see how it works, this is another good program, see how it does, how it works, sure, you can learn from that. But the one thing I'm not teaching you is actually programming, okay? So showing you good example of the finished product, the piece of code that does X, Y, Z, whatever, X, Y, Z as a requirement, just showing you the finished piece of code is a way to learn programming, but it's a way to learn programming that doesn't ever speak about what it is that we do when we program. I just expect you all to just figure it out on your own. And this has been like that for decades, okay? Nowadays, a more modern way to teach programming is to say, if I want to teach you programming, I'm going to break down what it means to program. Break down this thing that can look like a monolithic, a one-piece, skill, and break it down into its component and teach you pretty much how to think like a programmer, okay? Because at the end of the day, that's the most important part. Is it critical that you are good with Java at the end of the semester? Not really. We are like learning a subset of Java to start off with. So you're not going to be like a super Java programmer by the end of the semester. You'll learn just a subset of basic Java stuff that we covered. What is the essential part? Breaking down problem, breaking down complexity, okay? Somebody comes at you with like requirements, I want this and this and this and this and this. You take that mess, you reorder it on paper in your mind, you go to the computer, and by the time you talk to the computer, you are clear, and you describe step by step a recipe to follow that will achieve the result you target. That's it. Okay? So module 2 is going to start us thinking about a few of those component skills, sub-skills that make up the programming skill as a whole. Okay? And module 3 is going to finish that overview. By the time we are done module 2, module 3, you'll have seen all the building blocks, everything that a program can do in this course in module 1. And then you will have a process in your mind, a sort of recipe to follow that tells you how to take any set of requirements and break them down, analyze them, dissect them until you can generate an algorithm as a solution, a sequence of steps, and translate it into Java so that the computer understands what you're talking about. That's it. So module 2, more specifically, is going to be about the simplest of the skills. We always start from the point 0 in this class, okay? I don't ask you many prerequisites. If you have prerequisites, good, but I don't ask you many. So we're going to start with the basic stuff, which is reading code, understanding code. So even just to do that, there are actually 3 different things that are happening in your brain when you're trying to understand code, read code, okay? The first thing is, are you able to read Java code and translate it to English? That's trivial, okay? I have to be honest with you. If you have problem with that, it's just because you didn't put enough work into learning the stuff, right? It's like if I tell you we are going to learn some words in German, and I write, this is a word in English, this is a word in German. Well, if we come next week and only half of you remember how to say train station in German, that's not because you're stupid or because you cannot learn it or because this is super complicated. It's because it's not interesting to you. You didn't put in the effort. I've done that in some of my classes. Okay? I paid the price. All right. There's no way around that. So this stuff here, I would say that without doing anything, most of you, the majority of students in this class are already there because we looked at building block, and as we looked at building block, we talked about them. So we know how to look at a piece of code and talk about what is this, a loop, what is this, a conditional statement, and so on and so forth. That's like the very, very, very basic way of looking at code, okay? The second way to look at code is to flip it around. What if you are on the phone and somebody tells you, okay, I need you to write a piece of code for me. You have access to your computer? Yeah? Okay, so here we go. Declare a variable int x, initialize to 0, then do this, then do that. Then what if somebody gives you step-by-step instructions, detailed as they can come, so that would be an algorithm, right? What if somebody gives you an algorithm in English and expects you to just do the part of the job that is translating to Java? What is that going to require you to know? The same thing than this. So once you know how to talk about code, you flip it around and somebody can talk about code to you and you can translate in Java. Again, from a cognitive level, okay, this is memorization. It's easy. If you don't memorize it, you'll never be able to do it. That's all. Third level, reading code is not like reading a novel. I've already started to seed that idea in your minds, right? Reading code is not like writing a novel. We don't go start to end in a linear way. Sometimes we start reading the code and there's a loop, so we follow the loop in our mind. What we do when we do that, we don't really read code anymore. We simulate the execution of the code in our head. We say, when this code is actually executed by the computer, this is what's going to happen. So it's not going to be linear. Sometimes I'm going to bump into an if statement. I'm going to choose one block instead of the other. Then I'm going to enter a loop. Then I'm going to choose the other block. I'm going to enter a loop, choose the other block again. There is a structure, there's a pattern, there's a path of execution through the code. So the code is just text, it's static, you write it once, it doesn't change, right? But then when you run the code, the way that you follow the instruction has pretty much a life of its own. This is a runtime. This is the execution path inside your code. So we are going to see in this module that once we are done with the trivial stuff up there, okay, especially this one is going to go very fast. But once we are done with that trivial stuff, then we are going to learn to look at code and trace it. So just reading code, this is really, I just put it for the sake of completude. There's going to be a few slides, but this is trivial. Reading code, being able to have somebody tell you about code and translate on the fly the English into Java, we are going to call that implementing. How many people had already a programming course before? It should be, about like half of you. So tell me again, keep your hands up, please. And tell me again, how many of you had a programming course where programming was actually what I call implementing here? You were given an algorithm and you were asked to translate it in Java, Python, whatever. Some of you, okay? That's very common. Like very first introduction to programming, people tend to do that kind of stuff, okay? We are not going to do that stuff here because the truth is that it's not programming. I don't know how to call that. Maybe it's coding, and even people who code actually would be mad at me if I call that coding. My point is that translating a solution in English, an algorithm, right, a step-by-step solution into Java or Python, yeah, it has to do with programming. You need to know what? You need to be familiar with programming concepts, and you need to know Python or Java. But what's the part that's missing in this whole thing? Yeah? Problem solving, exactly. When people give you the algorithm, when people give you the step-by-step instruction they want you to translate into Java, they've already solved the problem, okay? So it's not unusual for like first contact with programming, the course is trying to make it easy, etc. And pretty much we expect you to learn coding, okay? Difference in this class, we are going to learn programming, problem solving included, okay? So we are not going to skip the actual interesting and at the same time hard part. All right, so what are we going to have in this module? We are going to have a practice quiz, a graded quiz. So it's going to work a little differently because as I'm trying to break down programming into a series of skills, being able to read code, implementing, tracing, and stuff like that, we see already 3 of them profiling at the horizon, right? As I'm breaking down programming into sub-skills, okay, there are some skills that are easy to test one way, some skills that are easy to test another way. For example, your tracing skills, being able to actually not just read code, but simulate in your mind the execution of code so that you understand what code does when it runs on the computer, right? This, we are going to practice it mostly with the PQs and the GQs, okay? Including there's going to be another one short, just one question cooperative GQ. It's going to be also about tracing. Because this is easy to test like that with a quiz. I can give you a quiz and you can get a lot of practice and you get immediate feedback. You get corrected by the computer and at the same time you don't lose points until you take the GQ. But by the time you take the GQ, the deal is the PQ should have prepared you, right? And then we have this other skill that I call implementing, translating from plain English to Java or plain English to Python. That stuff, I need to give you an algorithm. So I need to give you like a paragraph, half a page of text that say declare this, do this, add this, subtract this, make a loop, do this, etc. As detailed as I can make it, and also as clear as I can make it, even though I'm using English. You're going to see what I mean when we start getting into ambiguous statement, right? But right now, I'm going to do that with practice exercise. I give you an algorithm, you translate it in Java, okay? To a certain extent, we are going to do that with a graded exercise. We're starting coding bat. Yeah. Okay. We are going to start using coding bat at last. We are ready. We are this close. I just need to show you once, how to go back and forth between JGrasp and coding bat, and you guys are good to go. But this one, watch out. This one is already anticipating a little bit on the next step. So this is going to make you practice your implementing skills. This, the IE is going to actually grade your implementing skills. So you're going to get feedback pretty fast on both tracing and implementing skill. And this one here is going to make you stretch a little your implementing skill to prepare you for the next module, okay? So that's the plan. That's the plan for this module. So GQ02 on tracing code. We have a cooperative GQ that I just released this morning. So this one has only one question. Like I told you, I'm not trying to make those huge. Okay. Eventually, if when I survey you, you tell me we prefer GQ or we prefer CGQ, one of them is more useful and you explain to me why, and I understand what works, what doesn't work, then I'm going to only keep probably one of them. But right now, I want the GQ because they're thorough. They go into detail in the reading assignment. This is what they are good at. Or when we don't have a reading assignment, they're good at making you practice those skills. And I want the CGQ to see if we can do better than GQs, okay? So I just have one question in it, but that one is going to take you a little bit more time. So I'm still in the frame of mind of you should spend maybe 10, 15 minutes answering your cooperative GQ, right? So CGQ 01, it's done. It's not graded yet. Okay, I had two students that had to take it a little late this weekend. So what I did is I re-released them step 1, step 2 for those two students. I still have to grade it. I will try to do it sometime this week. So you will have your grade fast. But if you connect to the server right now, you can see the solution. Okay. And last time I said, I'm going to jinx it. We don't have bugs, and ended up. I think the only problem we had last time was that the server underneath the application, the virtual machine, was crashing. It crashed twice between Tuesdays and Wednesday, I think, something like that, or Wednesday and Thursday, I don't remember. So I'm going to reiterate that. Bugs have been fixed. We are going to have no problem at all with this release of the software. All right? See me like next lecture where I'm going to explain to you what went wrong. All right. So IE02, this is going to be, that is why I wanted to wait, okay? I didn't want to make a IE01 that was meaningless. This is what IEs are good at. You guys are going to code. I'm going to give you in an IE an algorithm in English. You are going to code it in Java, write your own Java file, upload that Java file, and that's it. Two things to be careful about. When you upload a file, this is a bug, it's not a feature, but Canvas is picky. When you pick a file to upload in an exam, okay, be careful, pick the right file. Because if you upload the wrong file, and then you say, well, it doesn't let me upload a second file, then you're going to say, I want to remove that file. And you would think that Canvas lets you replace it by a new file. No, it's a mess, okay? Canvas is a little picky about that. I don't know if they fixed it this semester. We have been waiting for that for like a few years now. Bottom line is when you say, I'm going to upload my file, when you click the button, you select your file and you click submit, make sure, pay attention, be mindful, make sure you don't mess up. You have to pick the .java file, not the .class file. And if you pick the wrong file, well, then there's a problem. If that happens during an exam, don't freak out. Stay with Proctorio, open Canvas message, and send a message to me and all of the TA. You can select, teaching assistant, all TAs, and attach your file, your Java file there. But if you upload the .class file and then you attach the .class file when you send us a message, we're going to have really, really trouble helping you, okay? So be careful about that kind of stuff. But at least if Canvas doesn't work out for you, you know that you have kind of like a plan B, okay? Send the stuff by Canvas message immediately while you're still being proctored. And also, if you upload stuff that doesn't compile, without compilation error, you get 0. Very important. Compilation error, that doesn't mean your code does everything the requirements say it should do. No, it doesn't mean your code doesn't run and crash or run and maybe gives wrong answer. All of that we're going to work with you. But the minimum that we require from you is when you upload a piece of Java code, it has to be a piece of Java code. Not a bunch of statements, that don't even match curly brace, etc., that mean nothing, that we cannot do anything with, okay? And the reason for that is that people that do that mean you just spend like whatever the duration of the exam was, like 1 hour, 2 hours, you just spend 1 hour writing on code and you didn't even test it. You didn't compile it because it didn't compile. You were not able to see how it runs. You were not able to test it. So pretty much you didn't program. You just wrote things that you thought were going to maybe net you a few partial points for partial credit, right? No, that's not programming. GE2, coding bat. So we need to talk about coding bat a little bit. Let me open up coding bat. We are going to look at an example together. So I have a basic JGrasp thing here. Let me jump right here. I just needed a basic exercise. So if I go to our Canvas page, you are going to see a bunch of exercises listed. I'm going to actually share that with you. in a second once I am there. So we're going to have a bunch of exercise listed in module 2. Each of them is going to have an independent link. Okay, so for example, here we go. If I go to module 2, so module 2 is not yet released, it's going to be released this afternoon sometime, but what you're going to see is G02 graded exercise and this kind of stuff. Okay, so click on one, it should catapult you directly to CodingBat. Make sure that you're logged in. And then here are the exercises. So these are exercises that are part of CodingBat, but I modified them a little bit to make them stick a little closer to the goal of this module implementing, right? So I give you the goal of the program, the requirement. And then I tell you, these are the variables that you need to declare and initialize at the beginning of your method. And these are the steps that you need to follow. And this is pseudocode. This is almost code. There's maybe a little bit of ambiguity. And this time, I try to make it so straightforward, okay? We are just starting, so it looks almost like code. As we progress, and as I'm going to show you in the slide, progressively, you and I are going to take shortcuts. Meaning that instead of writing a piece of text like that that is indented even to look like code, I'm just going to tell you, well, you know, when this happened, this should happen, and this happened, this should happen. And I'm going to be more and more casual with the way that I express requirement. And your job is still to absorb that casualness, you know, ask question when I'm ambiguous, and then translate into Java. But at the beginning, the translation, I'll try to make it as straightforward as possible. So everybody should be on board with that. And then this is your CodingBat window. And here's what's happening. So you are told here, you are going to write a method, first thing, okay? So this method, public Boolean, this is the name of the method, generally the name of the exercise. This one, this particular method returns a Boolean value. It returns true or false, and it takes as parameter a number of squirrels and a number of walnuts. You'll see the story in the exercise description, okay? So you give me two numbers. These are kind of like variables for my method, parameters, right? And I'm going to return true or false. So let's start by writing the simplest version of this method, return true, or I could say return false even, it doesn't matter. This is going to be working sometime and not working most of the time, okay? So this is the table. And yeah, I'm scrolling the right thing here. This is a table with all the tests, okay? So when you click the go button, if your code doesn't compile, it's going to tell you compilation error and a message, just like JGrass would do, okay? If it compiles, it's going to run it. Assuming you don't have an infinite loop or something that never ends, okay? The code is going to run, come to a result, and that's going to show you the first test. Then it's going to run again, run again, run again. What are those runs? Those runs are calling on the server, on the CodingBat server, they are calling your method. So you didn't write a main, right? You didn't write a main, you didn't define a class. You just gave CodingBat the code for one method. And CodingBat took the code for that method, put it inside a main of its own on the server, and ran it. Ran it by calling it with different parameters. So this means when I call your method with 1 for the number of squirrels and 14 for the number of walnuts, this is what I expect. I expect your method to return false. So CodingBat tells you that. CodingBat has already a list of tests ready to run on your code. And then it tells you, but when I ran your code, because my code only says return true every time, this is what your code returned, true. I expected false, you return true, the test failed. So your code is not compliant with the requirement, and so on and so forth, okay? A bunch of code. So when you look at that, it tells you, well, you know, when you give me 11 and 22, for whatever reason, because I really didn't even read the exercise, for whatever reason, when you give me 11 and 22, the answer is true. So by always answering true to whatever question you ask me, I get it right. But it's sheer luck, it's dumb luck, right? But then if you pass through me 1 and 14, for example, it's wrong. So now you can use those tests. You can say, okay, what would I have to do to pass the first test? You're going to look at the description, you're going to look at the algorithm, start implementing it. Pay attention to what happened exactly when I am given 1 and 14. By the time you're done implementing all of this, all of your tests should be green. When all your tests are green for an exercise, you know you're going to get full credit for it. So you don't get credit immediately, but at the end of the week or during the weekend or whatever, okay, I run a little script, I update your grades. That script is going to look at CodingBat using the URL that you guys were kind enough to share with us, right? You're going to go to CodingBat, check what you have done, check that you've done that exercise, check that all the tests are green, and if all the tests are green, it gives you credit, put the grade in the grade book for the item GE02. Yeah.
So we have infinite attempts until we get them all green?
Yes. And you have infinite tests, infinite time. Wow.
And if our most recent one isn't green, it's that one.
Yeah. Unfortunately, if your most recent one, if you get it all green, and then you say, hey, I want to play a little bit, and then you get some red, okay? And then you say, okay, I'm done for now. You quit, then it's the last version of your code that is going to be considered for grading, okay? So make sure that when you stop working on an exercise, if you solved it already, that you revert back to all green, okay? You can just comment out things here, you know, save them in a text file, save them in JGraphs, I'm going to show you how, and stuff like that, okay? So, what else? What else is important here? That's pretty much it. The last remark I wanted to tell you about logistics and the grading process. Every time I run the script, okay, it's going to check every exercise in the semester that have been assigned so far and check if you have done them and give you the points. Which means that if by the deadline you cannot get that test to pass, you don't understand it, by the deadline, you are going to not get credit for that exercise, but get credit maybe for all of the other exercise. 2 weeks later, if you finally come back to this code and get it to pass all the tests, you will get retroactively credit for it. This is again, I try to separate clearly what is grading your performance, like an IE, a final exam, okay? And what is rewarding you for learning correctly how to do the stuff, okay? This is rewarding you for persevering, for putting effort into it, okay? So bottom line is that I would hope, you know, by the end of the semester, everybody has 100% on all of the G. That's actually the goal. All right, what else? Well, I need to tell you a little bit about connecting this, what you do here, with JGraphs, okay? It's not strictly necessary, but I want to give you the full picture. So what are we writing here? I already told you we don't write a main. We don't write a class definition. We have just like a piece of the code that we have been writing in JGraphs, which is the definition of a method. Is there something weird about the definition of this method? Who's good at Where's Waldo? Yeah. Yeah, bingo. So the static keyword disappeared. Yes, that's the difference between CodingBat and JGraphs. For CodingBat to be able to take your code here and put it inside a class of its own and run it, call your method with all those parameters, it needs your method to not be static. But that's about it. Okay, that's about the only difference. Yeah. So I didn't say it yet, okay? But what it means pretty much is what we write in JGraph, and we're going to write like in IEs and final exam, etc. What we write as static method, that means method that can be called like that from the class, okay? If you have a class with a bunch of methods in them, you can say, for example, math.sqrt. Math is the name of the class, .sqrt, you call the method inside the class, okay? That's the easiest way to write method and call method in Java. A non-static method, that means that CodingBat has a little bit more work to do in order to be able to run your code. It needs to first put it into a class definition, and then it's going to have to create an object of that class, and then it's going to have to call the method on that object. They could have just as easily asked us to make static method. That's the reason for which I do it with you, is because when you make a static method, you don't have to do extra steps to run your method. That's pretty much the reason behind it. Does that make sense? I'm trying to go around, right? Not give you like all the gory details, but at the same time, give you a good idea. So, and if that's not enough detail, come and see me at the end of the class or whatever, everyone, right? And I will fill in more blanks. Right now, what I would like to do is I would like to take this. So the editor here is okay, all right? The editor in the web page is okay. It's usable, but sometimes I have students that really cannot stomach it. They hate it, and they want to be able to use JGrass. So how would I use JGrass, for example, to work on this problem? Well, I would have an empty file, right? Just an empty class definition and a main method. And this is actually what CodingBat does with your code. It takes your code, it pastes it in a class definition, right? So now I have a method squirrel party analyzer. If you work on it with JGrass because you like the environment better than the web page, okay? If you work on it with JGrass, you are going to have to temporarily make it static. Public static, blah, 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 okay? When you cut and paste this to put it back into CodingBat, if you want to go back and forth, remember to remove the static. That's the only trick that can throw you off balance. But if I try to compile this, for example, it's going to tell me, yes, it compiles. So what else does JavaBat do for you? Well, let's take a look real quick. Where is my JavaBat window? Lost, apparently. There we go. So let's take one of those tests, okay? So we're going to take, like, for example, the first test takes 1 and 14, right? Yep. We're going to take that one, and we're going to say, I'm going to call squirrel. I'm going to first get into the right window. That helps. And then I'm going to call squirrel. It's Monday. That's my excuse. Party analyzer. And then I'm going to pass 1 and 14, okay? If I call it like that, try to compile, no typo, no syntax error, yeah, call the method. Then the method returns something. So this is replaced by the value being returned, true or false. And then I don't do anything with it. So that's why nothing happened. If I run the code, here we go, run the code, nothing happened. So then I'm going to say, for example, Boolean result equal this. And then system.out.println. So I'm going to say print I expected. What did I expect actually? I expected true or false. Let me go back real quick. I expected true. No, wait. A false. Okay, I expected a false. So I'm going to say in my code here, I expected as a return value from this false. System.out.println. I observed, and then keep doing that. Print observed, and then system.out.println, whatever the method actually returned. So compile this, run it. I expected false. I observed the return value true. This is how you run tests on code. This is another reason for which we are going to package our code in method. When you put your code in method, when you say this method takes those parameters and return that value and does blah, okay, whatever side effects it does. You have well defined the goal of the method. Now I can test your method. I can call your method independently and I can call it 50 million times and say, okay, I give you this and this parameter. What do? You return to me something. I hard code here what I expect, and I can even use an if statement to compare it to what you return. If what you return is false, for this test, I display test successful, green box in CodingBat. If it's not the same, then I display test failed. This is what your method returned instead of false, okay? There's no magic. This is exactly what CodingBat is doing for you, okay? So my suggestion would be work in the web page, get used to it, okay? The editor is really not that bad, but I wanted to show you how what you do in CodingBat connects to what we've learned to do so far in JGrass. It's still the same thing, except for that keyword static that we have to add when we are in JGrass, and we do not need when we are in CodingBat. All right, so that's pretty much it for the link with coding bat. So I'm going to close this now, and we are going to go back to where we were in the slideshow. So static keyword, this I already mentioned it last time, okay? Every time you write a method in coding bat, my advice to you is declare a variable result, first line in that method of the data type that is the data type you need to return, and initialize it to 0 or false depending on its type, and then write the code that determine what the value should be, and at the end of the method, return the content of the variable result. If you want to test in GeoGraph, you can do it like I just showed you. And I'm going to introduce here a new Boolean operator, real quick, a little bit of syntax. It's just the exclamation mark. So how does that work? Well, the exclamation mark allows you to say not. So for example, if I have an if statement, I'm going to put an if statement here. For example, I'm going to say, after I do all of this, I'm going to say if. So this is how I write my if statement, remember? Put everything and then fill in the blank. So if result equal false, then I want to display system.out.println success. The test succeeded, okay? And if that is false, then I want to display failure. The test failed, okay? So I can run it like that. If I wanted to do the opposite, so take this, put it there, take this, put it there, okay? I could either test different, like this, or I could just negate my condition. So if negation of, and I'm going to be a little verbose for the parentheses right now, but if negation of result equal true, then do something. So if not that expression is true, do something. If that expression is true, not true is false. So we reverse pretty much the outcome of that expression. If it's true, it becomes false. If it's false, it becomes true. Just negation, okay, Boolean negation. And this is just a little bit of syntax I want to throw in because it's going to sometime allow you to write things a little bit more easily in coding bat, because a lot of the coding bat exercise are going to ask you to return Booleans, are going to ask you to return values, etc. So your if statement, sometimes you want the else part to be inside the if, you can do that very easily by negating your condition. Sounds good so far? Any question? All right, cool. All right, moving on then. So we talked about that very first trivial part of the skill, which is translating from Java to English. So I'm going to go fast over those slides, okay? Again, if you want me to slow down, say something, if you have questions, they are more than welcome, okay? But this is really trivial stuff that we already have kind of rehashed a few times, okay? So I already told you about the importance of memorizing and recall for this. You can take index cards if you haven't done so yet and say, on one side, this is how I read an integer value from the user, and then write the code pattern. I don't have to put the main definition. I don't have to put the class definition. I'm just putting the pieces of code that I know I will need to add to a program in order to do this task, okay? For example, I need to import the scanner, then there's going to be more code. Then somewhere in one of my methods, I need to create and initialize a scanner. Then I need to have a value variable or whatever I want to call it to take the value from the user. This is where I take the value from the user. And after that, I do something with it. Here I display it, but I could do any sort of computation, okay? Once you memorize this, I want you to take time to go over those slides. So there are going to be like about 5-6 slides that we are going to go real fast over in class, but I want you to take the time to reread them, okay? Because that's all there is to those slides. Getting you used to different phrasings, okay? So I'm going to go over some of them, and then the rest, just reread it as part of a reading assignment, let's call it that, and it will help you get used to how things are described when a programmer talks to another programmer. Here's some code. Int x equals 42, semicolon. How do I read this? We are going to go always from most verbose to more casual. Most verbose is, I have on the phone a beginning programmer. I don't want to confuse them. So I tell them, declare a variable named x of data type int and initialize it to the value 42. I cannot be more pedantic than this. I tried, I can't. Okay. If you find a way to phrase that more pedantic, then please share with me. I'd be curious to see that. Okay. Bottom line is that yes, it's 100% correct. It's 100% unambiguous. But what I'm going to say to my colleagues when I work with them, if I have to tell somebody declare an int variable x equal to 42, I'm going to tell them declare an int initialized to 42. I don't have to say declare a variable. Of course, it's declare a variable. You and I have been working on this stuff, for like years. We know that we need to declare variables, right? If I tell you I need an int, that means I need an int variable. So we are taking shortcuts, okay? And then declare x initialized to 42. Where is my data type? I didn't even bother telling you that I wanted an int because now I'm relying on you to look at this value and say, so x is a variable. The value you want me to initialize it with is 42. That's an int. It's not 42.0. So I'm going to use the data type int. And that's one of the things, this is not the worst thing in programming, okay? But that's one of the things that sometimes students come to me and talk about and they say, I'm really confused about how the problems are phrased, okay? I understand, for example, in the lecture, I understand in the textbook, but this exercise here, I don't understand how things are phrased. Yes, it's because here we are using a formal language, a programming language. This is actually better. For me, this is better. I like this. This is clear, unambiguous, no problem. And then, as you try to express the same idea in any natural language, you end up being super verbose, or you end up skipping sometimes important parts. And you expect that whoever you're talking to is going to fill in the blanks for you because you and that person, understand each other, right? Well, yeah, that's kind of like getting into the subjective world, right? So you have to be prepared for that. Even if somebody gives you like an algorithm, if I give you an algorithm and say declare x set to 42, don't get lost. Okay, there's only 6 building blocks that we know of. This one definitely corresponds to declaring a variable, and now you can work out the detail. But yes, you will have to fill in the blanks sometimes. Okay, double price in dollars equal 23.9. Declares the floating point variable price in dollar to be equal to 23.9 verbose. I want price in dollars initialized to 23.9. Just same thing, okay? This one, the scanner, look at this. Declare a reference variable S. I could say, declare a reference variable named S, meant to hold a reference to an object of class scanner and initialize it to a new object of that class created using the one parameter constructor to which we pass system.in. That's the slide here. This is what we say in COP2513. But by the time I've talked like that with you, you are going to understand the meaning behind every single word here, okay? So this is super detailed. This is me trying to narrate code in all excruciating detail. But what I'm going to tell you in this class, I'm going to tell you, for example, declare and initialize a scanner named S. Where is my variable? Where is the data type? Where is system.in? You didn't even mention system.in. Yes, we take shortcuts. Okay, as the jargon settles in, as we get used to declaring that scanner 1 time, 5 times, 10 times, when I've done it 50 times, I'm tired of saying, the first sentence. I just say, give me a scanner. That's it. And that implies the whole thing. Okay? Same thing. So that was building block 1, by the way. Building block 2, assigning values. Again, assign the value 42 to the variable x. More pedantic than that, maybe assign the value 42 of data type int to the variable x. We can be like super detailed. Set x to 42. That's it. If I set a value to x, x has to be a variable. X is not the name of a class. You see how I'm using what I've learned, what I'm familiar with to take shortcuts. It happens in every field. That's called the jargon. Okay. So when I talk to you in this course, I'm going to be super pedantic at the beginning. And as progressively as we go through the semester, as you have been doing, 50 million of times, declaring a scanner, etc., we are going to take some liberties, and that's going to get you closer to the language as it is used, for example, in the textbook. The exercise in the textbook, they are kind of in between. Sometimes they go right here, sometimes they go middle, but they don't make it a duty, to be super clear to you. Because in real life, that's not how we talk, okay? So again, here, another example of how to translate that assignment. And then calling method, I can go on like that. Let me see which one is actually interesting. This one maybe is the most interesting. Compute, insert formula here. So here I have like 2 lines explaining to you what I'm doing, what mathematically I'm doing, okay? But really for you, what does it boil down to? You compute a value with a formula and assign the result to variable y equal the formula, and that's it, okay? So right now, read it left to right. Look at this code. Tell yourself in your head, okay, this is what it means. Double check that this is compatible, what you said it meant, that's compatible with one of the version here, okay? Train yourself to use a shortcut version, use the jargon progressively, okay? And then we're going to reverse that. We're going to go from the right to the left. Conditional statement and loops, so BB4, BB5, they are getting really annoying. And I encounter that when I write, for example, IE02. Every semester when I prepare IE02, it takes me more time to write actually the instruction for IE02 and try to make them clear in English than if I wrote actually the code for IE2 and gave you the code, okay? See the size here? Things like, for example, test whether the value contained in the variable x is lesser than 42, strictly lesser than, not lesser equal, right? But I have to say that because if I say lesser to somebody, maybe they might misinterpret and think lesser equal. I don't know. So if the previous test results in the Boolean value true, then execute statement block 1. If the result is false, execute statement block 2. Okay, this is how I'm going to say it most of the time, very fast, okay? If x is lesser than 42, do something else, do something else. And that's it. Now, in the first examples, like for example, the coding bat example, I even indented my English sentence. If x is lesser than 42, then go to the next line. Then do something, else do something, and the indentation should use the structure pretty much of the if-else statement. But that's not going to happen like that. At the final exam, in the exercise in the textbook, you're going to get a bunch of sentences like that, and the sentences are going to be slapped together. And then if there are multiple if statements in the sentences, do they mean that you have to write them one after the other? Or do they mean that you have to write them one inside the other? I don't know. Figure it out. And this, I don't have any problem telling you figure it out because this is not programming. This is English. Okay, if I write a block of text here, and that block of text should represent 2 logical if statements, one after the other, and I write another block of text, and that one should represent an if statement with another if statement nested, it's going to take me a paragraph to make that clear. If I want to be 100% sure nobody in the room misunderstands me, it's going to take me a lot of work to do that in English. I would much prefer writing the code, right? But that's part of the deal. When people give you algorithm, they use plain English. When you talk about your code with another programmer, you use plain English. You need to be able to go back and forth, but watch out for the missing details. BB5, here's a loop. I like this one because this is a loop. This is a counter control loop that's going to display woot on the screen, and it's going to display it 5 times, okay? So the way that I summarize this is display woot on the screen 5 times. And that's it. If I tell you that, this is an algorithm. Now, the correct way to say is declare an int initialized to 5, blah, 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 etc. Yeah, sure, this is more detailed, but this should be okay. By the end of the semester, this is how you're going to think about your counter control loop. That single sentence encompasses a lot of stuff that we already covered together. And I think this is the last one. So that is starting to look like the kind of stuff you're going to get in IE2, okay? This is a pedantic, long description of what I want you to do with a loop. And what I want you to do with a loop, I'm not going to even look at this. What I want you to do with a loop is you have some input variable that's going to come from the user. I'm using a scanner to read it. While the input is greater than 0, that looks like a sentinel control loop, right? You're going to ask the user enter a value. You are going to read that value. You're going to display a blank line, add that value to the variable sum, and keep adding to the variable sum whatever the user enters. Yeah. Uh-huh. So a do-while loop, we didn't talk about those yet, but do-while loop is also possibly a sentinel control loop. It's also possibly a counter control loop, or even a general purpose loop, okay? It's just a different syntax in Java, okay? So for everybody else, while is a keyword that allows you to implement loops in Java. Do-while is another one. Why didn't I introduce do-while? Because we can do everything we do with do-while with while, sometimes with a little bit of effort, right? So we don't need right now to have like two different types of loop. Let's focus on one type of loop. But eventually, yes, we're going to talk about do-while. We're going to talk about for. There are like three main ways to write loops in Java, okay? And this is the best actually way of approximating this code, where you don't deal with the detail. You just pretty much you are moving toward saying what the code does, but not necessarily how it does it. And that's ultimately what requirements are going to be. Requirements are never going to tell you step by step what you need to write in the code. They're going to tell you what the code should be doing. So we are moving progressively toward that. I'm going to go fast over this. It's not worth like us spending too much time, but this is a code that I used in the previous slide. It's supposed to add the values that the user types to a variable sum. So if I type 1, 2, 3, I want the sum to become 1, then 1 plus 2, then 1 plus 2 plus 3. And at the end, it's going to display the sum of all the number you entered is 6. But I said something here. I said, as long as you enter a positive value, I keep reading. And then when you enter a negative value, I stop. So if I describe what the code is supposed to do like this, the requirements, is this code actually fulfilling the requirement? Is it complying with the requirement? Or is there something wrong with it? Yeah. Something is never declared? What? Oh, sum is declared initialized here. No, we're good for that. Yeah. I'm okay with sum being initialized before. Like before we start the program, as we start the program, sorry, sum is set to 0. Then as I go here, I read a number, put it into sum, add it into sum. Yes. That while loop, good question. This is the stuff that you need to pay attention to. The while loop will end. Okay. If I enter the value -1, so I'm going to read -1 from the keyboard, put it in the variable input, and then I'm going to display a blank line, add input to sum, and then I'm going to detect, oh, input was -1, so -1 is not greater or equal to 0. Therefore, I stop the loop. Okay. So at that point, I will jump here. Does that make sense? Yeah. What else? Yes, these are actually the essential question. Okay, we'll talk more about that when we do debugging. But yeah, every time you have a loop, what can go wrong? I cannot get into the loop ever, or I can never get out of it. So this is exactly how you need to think about code, right? So this is good stuff. That loop will start. How do I check that? Input is originally 0. Okay, so while input greater or equal to 0, checks. So I can enter the loop. Even though technically I didn't read anything from the user. That's the thing that should bother you, right? I didn't read anything from the user, but I initialized my variable so that it would go through the first test, allow me to read something from the user, add it to the sum, and then check, did the user enter a negative number? If it was negative, I'm done. So yes, we get into that one, but we were careful to make it so that we get into it. That could be a source of bug, yeah. Anything else? So yeah, go ahead. Yeah. Yep. The s.nextthing is going to pause, to freeze execution. It's going to wait for me to type a number. When I hit enter, s.nextthing convert what I typed to an int and returns the value. Okay? So that's where the user input is being processed. Let's say, I don't remember what are the numbers that I've been using. What I've been using. Let's say that I enter 10, enter, 20, enter, and then minus 10. What is going to be the sum being displayed on the screen? So 10, 20, and minus 10. 10 plus 20, 30, minus 10, 20. Yeah. Is it really what I wanted? No. Because I told you I want to make the sum of everything that you type. And then I want you to type a negative number to tell me I'm done. So the negative number is supposed to be the sentinel. It's supposed to be what tells me the user is done playing with my code. But I should not add it to the sum variable. Okay? So that piece of code here, we are going to play with different versions of that code, okay? But it's not actually doing exactly what we said it was going to do. Read numbers from the user, add them up until the user enters a negative value. But you see again, the English version of the code, it's flawed, it's ambiguous. If I tell somebody, keep getting, numbers, and then until you find a negative number, the person is going to see the negative number, stop working. That's it. They did what I wanted them to do. Another person going to read the same instruction and say a negative number, add it to the sum. Technically, I cannot be mad at them. My instructions were unclear. Code is never unclear, okay? But sometimes you read requirements, and yes, you have to fill in the blank. So for example, in this case, I would have to say there are many ways to do it. Okay, this is just one of the possible ways. But I could say if input is greater or equal than 0, then add the input. Else, and you see that I skipped the else part here because if the else is empty, you can remove it completely, right? Else, I don't do anything, and then I reach the end of my loop and I check again. Was input -1, by the way, or was it a negative number? If it was a negative number, get out. If it was not a negative number, do it again. So this if statement allows me to say, if the input is not the sentinel value, okay, then use it. But only if it's not the sentinel value. If it's the sentinel value, skip, and then reach the end of the loop, and you'll get out of the loop by yourself. Does that make sense? Yeah. Out of the three numbers? Well, in this case, in the case on the right, okay, I would enter 10. So let me trace it for you, okay? I would enter 10, so I start with input equals 0. Come here, sum equals 0, input greater than 0, enter a value, I type 10. So input is 10, okay? Input greater than 0, true. I add 10 to sum. So now sum is 10. I reach the end of the loop, go back. What is the input I just read? 10? Is it greater than 0? Yes. Give me another value. Now I type 20. So 20 is typed, 20 is put inside input. I test, is 20 greater than 0? Yes. So now I add 20 to sum. Sum contains 10. I add 20, I'm at 30. Okay? Reach the end of the if, end of the loop, go back. What value did you just type? 20? Yeah, that's greater than 0. So I go one more time. And this time I type -10 or -99 or whatever negative number, right? And they detect that it's negative, so I do not add it to the sum. So my sum stays at 30, 10 plus 20, and then I reach the end of the loop, go back here. If the input that you last entered, -10, is greater than 0, that's false. Bam, I'm done. And now I display the sum of all the numbers that you entered while you were still playing with me is 30. Yeah? So that's what I was saying, okay? I'm introducing here another syntax quirk. If you have an if else and the else is empty, so opening curly brace, closing curly brace, and you don't want anything in your else, then you can omit the else part. So you omit the else keyword, you omit the open curly brace, closing curly brace. So you have what you can call, if you want, a half if statement, okay? If something is true, do this. What if this is not true? What do? Well, we don't do this. So that means we go to the next statement after the if, right? So that makes code optional. If this is true, do this. Otherwise, never mind. As opposed to if this is true, do this. Else, do that. You have a choice. Okay? Make sense? All right. And I lied. There was one more slide about the building blocks. So what is this one? General loops. Okay, so this is not a big deal. This is another illustration of how I would translate a piece of code like this one, which is actually a piece of code we've seen already before, right? This is a loop that's going to add a bunch of numbers to sum. It's going to count 5 or something like that. What is it doing actually? N equal n minus 1. Oh, it reads a number from the user. So for example, if I type 5 for n, and then it's going to add 5 plus 4 plus 3 plus 2 plus 1. When it reaches 0, it stops, okay? Again, big description here. This is what you can expect for IE2. This is what you can expect at the end of the semester. And progressively, I'm going to go back and forth, back and forth, back and forth, and then stop being that verbose and get more and more abbreviated. All right. We're going to finish with this now, because now that we agree on how to read things, and now that you accept, this is really the deal here. I'm trying to get you to accept that sometimes statements that people make in natural language are ambiguous. Not because we try to trick you, but because it's a lot of work to try to be so accurate that you sound like a mathematical formula or you sound like a computer program. A mathematical formula, a computer program, you cannot misinterpret those. There are strict rules. English language, you can very much misinterpret. And even when you do your best to explain something to someone, maybe you use a little bit of jargon and now you just confuse them. I should know. This is what happens when you teach, right? I explain you something, you look at me, you say, no, I really don't get it. I explain to you differently. When I do that, I'm trying to make up for the fact that every single time I speak to a human being, we are using an ambiguous language, and maybe we don't see eye to eye. We don't really understand each other, right? So now we're going to flip that skill around, and we're going to say, okay, what's implementing? Well, implementing, as I said at the beginning, is the reverse translation. It's not the same as programming. It doesn't have that essential element, which is problem solving. So why do we bother talking about implementing today? Because when you tell me, and some of you will come at some point in the semester, and you will tell me programming is not my cup of tea. I don't like it. I try to do it. It doesn't come naturally, and really, I don't know how to program. Well, how do we react to that? So I'm going to look at you and I'm going to say, it's not that you don't know how to program. Is you have maybe a problem with one of the programming skills. Do you know how to, do you know what this is? I'll show you a loop. The student tells you, well, yeah, it's a loop. Do you know what kind of loop it is? Maybe the student thinks a little bit, counter control loop. You have no problem with reading code. Okay, now, can you write for me a counter control loop that counts from 1 to 5? If the student can just write this, then they know how to implement, right? So we break down the programming skill, and I really advise you to break it down in your mind. We break it down so that you can self-diagnose yourself. When you look at a problem and you say, I don't know what to do. No, don't get stuck like this. This is emotional response. This is, I really don't like that stuff. I don't want to do it. This is, no. This is emotional, logical. What part of programming is causing me problem? Do I understand the requirement, the English requirement? Do I know how to write a loop? And if you discover that you don't know how to write a loop, go work, go study. That's it. You just need to memorize it, right? So we are going to use that decomposition of programming to troubleshoot those of you who are going to encounter some problem. Trust me, we're going to zero in exactly on what is the nature of the problem. And this is what you get at IE02, okay? This is a good example. I encourage you to try to actually code it, implement it, okay? Here's a list of statements structured like an algorithm. I really try to make it, repeat the following statement. What am I talking about? A loop. Repeat the following statement until n is equal to 0. Is it a counter control loop? Could be, but until n is equal to 0, where does n come from? Declare an int value initialized to 0 that will be used to store the result of computing the sum of the first n integers, declare an initialized to 10 that will represent the number of integers we want this program to sum together. So I declare the variable here. Yeah, it's going to be a counter control loop. If I was reading n from the user, then that would be probably a sentinel control loop. See what I'm doing? So I'm navigating all those rules that I learned with a building block. I'm trying to map them. What is the best way to translate this? What is the best way to translate this? What is the best way to translate that? Do that. Practice. You are pretty much sculpting your brain. Okay. When you do that 5 times, if you do that 1 time, you're not doing anything. Okay. You're just listening to me talk. But if you do that 5, 10 times in different exercises, etc., what you are doing is you are training your brain to be quick at translating back and forth. And you don't need to do it 50 million times. You just do a few exercises that I recommend, and you will have your brain ready for the next step. Okay? But we have to work with our brain. We know what makes them retain information, what makes them just, forget everything. So we have to do it the right way. So, talking about what we have to do, practice exercise. So I'm going to insert the practice exercise when they become relevant in the slides themselves. So I'm giving you 5 practice exercises. Again, these are from the textbook, but because of the way I'm trying to teach you programming, without starting by just doing if statement and just doing loop, I try to teach you really the whole programming thing in a simplified way. They come from every chapter almost, okay? So if you were looking at 5.3 guess a number.java, maybe there are things that I didn't cover. So for that reason, I give you the code for those exercises along the slideshow. Okay, so you don't need to go in the textbook, you'll have them handy, and the code version that I give you uses only what we talked about in class. First slide for each of the exercise, first slide, this is an IE. That one is simple, okay? No loop, no if statement. But the goal is that this is what an IE will look like. And I ask you to translate it. Code it, run it, make sure it works. Then check the solution if you're lost. Okay, next slide is the solution. Don't just read the solution, by the way. It's kind of like, it's not training you. Again, you are going to learn a new solution to a new problem. So if I was to ask you exactly the same problem, you're going to memorize the solution, but you never actually put in the effort to train your brain to go from point A to point B, okay? So don't jump to the solution. Program 2, here's another IE. Code it, translate this in Java. Here's the solution. Another, and so on and so forth. Okay? So a first series of 4 exercises. The next IE will be next week, right? So we have like a week. This week, we are going to finish this module together. And then next week, we're going to start the next module. And at the end of the week, you'll have an IE that covers this module. You have pretty much the equivalent of 5 old exams here for you to practice with. Start now. Don't wait. Okay? Start. Yeah? Yeah. Yes. No. Sorry. You got me. You do the practice exercise in JGraphs. Okay. Remember, practice exercise, practice quiz, they're not graded. So you are going to use the slides that are going to be available after the lecture. You're going to look at what you have to write here. For example, the pseudocode, right? The algorithm. You're going to translate that in Java in JGraphs. Get it to work. And you can work with other classmates. You can come to TA for assistance. It's not graded. Make sense? Yes. So coding bat, it's not assigned on the slide, but inside of Canvas, you're going to find links. Okay, let me show you real quick here, if I can open it. Of course, I closed it, so give me 1 second. If I go to Canvas, all right, this is your module page. So it's not yet released. Module 2, this is not green, this is not released, but I'm going to release it today. You are going to find the slides, but you are going to find also some graded exercise. So practice exercise are not graded. You do them in JGraphs with friends, etc. Graded exercise, you work on them solo. You use coding bat, and that's going to give you a grade. So the practice exercise to develop the skills, the graded exercise for you to get a realistic evaluation of, okay, am I ready or not? And then the IE, to get a more thorough evaluation. Make sense? Yeah. don't hesitate to ask me whenever it doesn't make sense how we do things in the class. Trust me, there is a madness to the method, but sometimes it's not obvious or it's counterintuitive because you have a different way of learning. If that goes against your way of learning, talk to me, okay? I cannot promise you that I can adapt the class to every different way of learning in this room, but at least I can help you bridge it, understand it, make it your own pretty much, okay? All right, so I'm going to close this. What else do we have? We're almost done. The second part of the practice exercise, if you need more practice, so it's completely, you guys are adults, right? I'm going to treat you as adults. If you need no practice, you know already this stuff, then don't practice. Just come get an A, as an XAIE, and I'm happy. If you need to practice, then I'm giving you options. And you pick and choose what you need. For example, the 5 different programs that I gave you, the first one is very easy. If you get bored, you look at it, you say, oh my God, this is so boring. Jump to the last one. If you look at the last one, you say, I don't know where to start. Go back to the second one. Okay? Ramp up the difficulty progressively like that. This, same thing. If you need more practice, what I would say is take the following code examples that are going to be in the remaining slides. Okay? So I'm going to give you code. You're going to translate it into Java. Write it down. Don't just translate it in your head. There's nothing. It flies away. Write it down. Translate a piece of code in English. Then let it sit for 1 day. Then pick it up again. Try to read your own description and rewrite the code without looking at the original code. Rewrite the code from your description. Or maybe work together. Get in a pair or something like that. Each of you picks one of those exercises. Each of you looks at the code, translate it into English, and then you exchange. Here are my notes. I take your notes. And now I'll try to figure out what kind of program you were trying to describe to me. Okay? This is a very good exercise to learn to go back and forth, especially if you do it with someone else. This is going to be awesome because the chances that somebody is going to mess up are increasing. And that's exactly what you need, right? You need somebody to make ambiguous statement and force you to say, okay, what does he or she mean here? And you're going to go back to your building blocks, connect the dot, try to make an educated guess, okay? And then move on. All right, what else do we have? We should be done. So after this slide, you're going to get a list of 1, 2, 3, 4, 5, again, exercise, same deal. Here's the exercise. And this time I don't give you the solution, the English translation, okay? But translate those things into English and then try to re-implement them later based on your English translation, or translate them into English, pass them to somebody else, have them do the work. And we're going to stop here. Next time, we're going forward. So we have to talk about implementing. We're going to talk next time mainly about tracing code. All right, thank you, everyone.